Good morning or good afternoon, my turkeys. Today we're going to be covering parallel and perpendicular lines. So we're just going to do the intro, which is basically identify what makes it parallel and what makes it perpendicular. So make sure you have your highlighters. You need 2 of them. And of course your pencil. So we're going to go ahead and get started. So first today we're going to look at parallel lines and perpendicular. We're actually just going to look at their slopes today, and then tomorrow when I'm back we'll be graphing them. So the first thing we're going to identify is parallel lines and define it. So parallel lines never, ever, ever, never intersect. What does that mean? On a street, your sidewalks would never intersect. Cars would crash. So basically, as you see these lines, if they go on for infinity and beyond, they would never ever meet. They are equal distance from each other, and they would never end up crossing. So what is special about parallel lines is that parallel lines only are parallel if and only if they have the same slope. So we're going to go look at the slopes. I know this is pretty tiny. Let me see if I can get closer. But if you look at the equation, it says that y equals 2x. So if this is y equals 2x, that means that my slope equals 2. Okay? Now let's go look at this slope. And if you look closely, the slope on this one is m also equals 2. So that means they have the same slope. So that would be identified as parallel. Okay? Let's go look at these. If you go look at the slope on this one, it says 1/2 x. So that means the slope on this is m equals 1/2. If you look at the slope at this equation, that is also 1/2. So they both have the same slope of 1/2. Therefore, we would consider these lines parallel. All right, let's go ahead and switch off highlighters. So perpendicular. Perpendicular lines, by definitions, are lines that intersect at a 90-degree angle, which means if you were to do geometry, this is a symbol for 90 because they have a perfect corner of 90 degrees. So your doors, when you open a door, they have 4 perfect 90-degree angles. Anything that makes the tiles on the floor perfect 90-degree angles. So we will define perpendicular lines by if and only if the product remembers multiplication, of their slopes is a -1. So the only way this can happen is they have to meet 2 requirements. Ready? The first requirement is they have to have opposite signs. So one has to be positive, one has to be negative. The second requirement means that they have to be the reciprocal of each other. Now, what does reciprocal means? It means that they flip. So let's go look at these. If you look at them, they cross or intersect at a 90-degree angle. Whenever you see that box anywhere, that is considered 90 degrees. So I'm going to try to zoom in. You can see that the slope on this one, it says y equals 2x. Well, that means that the slope of this guy is m equals 2. If we go look at this equation, The slope on it says y equals negative 1/2. I think that's minus 2. So that means that the slope on this guy is m equals negative 1/2. So let's go look at this one. Ready? If I say this is 1/2 and it's negative, does it meet the criteria of the opposite, which the slope on this one is 2? Now remember, we could put a 1 underneath so it could look like a fraction. First of all, are they the opposite signs? Yes. This one's negative, this one's positive. Second, are they each other's reciprocal? Yes. A reciprocal means flipped. I have 1/2 and then this one flips 2/1. Therefore, this is considered perpendicular. I forgot to dot my I's. Okay? So let's go look at the next graph. The next graph meets there, and again we have a 90-degree angle. Therefore, they're saying it's perpendicular. But we have to make sure it satisfies the requirements. So one has to be opposite signs, and the other they have to be flipped, which they just basically flip on a fraction. So let's go look at the slopes. This one says that it is x equals -3. Now this one's tricky, because if it is x equals -3, what's my slope when it is perfectly vertical? My slope is undefined. Then we look at this equation, and it says that y equals -2. Well, on a y equals -2, that means it's a horizontal line, and a horizontal line, the slope is 0. So this one has a special case. We call it vertical being against a horizontal. So we're going to say that if they are one's undefined and one's 0, it will always make a 90-degree angle. So here's some special notes to take. If x equals any number, so basically x in this case was -3, it's going to be a perfect vertical line. I'm sorry. Sorry, I'm trying to write small. It's not working. And if you have y equaling a number, any number, in this case it's -2, that means that you're going to have a horizontal line and if you have a vertical line and a horizontal line, these two will always make the perpendicular. Oh, I misspelled it. There we go. Fixed it. All right. So ready? We're going to go ahead and start first identifying opposite reciprocal. We're going to practice what that looks like. So we're going to do 1, 2, 3, 4. So I'm going to do 2 of them, and then I need you guys to try. Maybe I'll do 3 of them. All right, here we go. So what is a reciprocal to 2/3? So reciprocal means I'm going to flip it. So that means the flip would be 3/2. So basically I've done the reciprocal of this, right? But now it wants the opposite. So remember, the opposite means plus and one's negative, and then reciprocal means they're flipped. So basically I've flipped. Now this one's positive, so I'm going to make this one negative. All right. If you want, you can pause the video and see if you get the next one right. But I'm going to keep going. So if this is 4, well, this is the same as saying 4 over 1. So I'm going to flip and make it 1/4. So the reciprocal to this would be 1/4. Now I have to make them the opposite signs. Because this one was positive, I'm going to make this one negative. So these two would be perpendicular. Okay, next. This is -1. Remember, -1 is the same as saying -1 over 1. So really, we can't really flip it. I mean, we can, but it's no big deal. It's still 1 over 1. The only thing different that's going to happen is it's going to be opposite. So this one's negative. I'm going to make this one positive. So this will be +1. All right. So hopefully you'll stop the video right now and try to do number 4 on your own. And then you can compare with your partners. I'm going to keep going. So this reciprocal would be 8 over 5. Now I'm going to do the opposite sign. This one's positive, so this would be negative. So these 4 would be considered perpendicular. All right, now we're going to get to determine whether they're parallel. So make a note, they have to have the same slope. Whether they're perpendicular, you can make a note by saying that they have to be opposite signs and they have to be flipped. And neither means they don't meet any of one of these requirements. So the way you're going to do this is you're going to pull out the slope. Ready? What is the slope to this equation? 1/2. What is the slope to this equation? Well, are these the same? Or are they perpendicular by being opposite sign and flipped? Well, I think they're the same. So I'm going to call these parallel. All right, number 6. Let's pull out the slope. On this one, the slope equals 3. On this one, the slope is -1/3. So first, let's look, are they opposite? Yes, this one's positive, this one's negative. Now we have to see, are they flipped? Well, we can technically say that this is 3 over 1, and that's the flip of 1/3. 1 over 3. So I'm going to call this, I don't want to write the whole word, so I'm going to write perpendicular. Because they are absolutely opposite signs and they're flipped. All right, number 7. This one's going to take some work, so I need for you guys to write really small. I know, this is going to be terrible. So right here where the little and sign is, you're like really going to write small. I'm so sorry. So we have to solve for y. What do I mean by that? I need to make this y equals mx plus b. So first I'm going to do is minus 3x. So sorry, it's so little space. So this is gone. I have 2y equals -3x plus 5. Take a breather. If you didn't understand what I did, rewind this so you can see what's left over. The -3x is left over plus 5. Next, I'm going to need the y by itself. Well, because this is multiplying, I'm going to divide by 2. Do all the way across. So now I have y equals -3/2 x plus 5/2. And all I care about is the slope. Okay? Let's go to this guy. Now I'm going to do this one. I'm going to do minus 2x to both sides. So I'm left with negative 3y equals 9. Oh, Miss Snell did it backwards. Sorry. I'll just keep it like that. We'll move it in a little bit. Now I need to get y by itself. So I'm going to do the opposite. This is multiplying. So I'm going to divide by negative 3 to everything. This cancels. Now I have y equals, well, 9 divided by negative 3 is a negative 3. Negative 2 divided by a negative 3 is a positive 2/3 x. Now remember, whatever's in front of x is your slope. So I'm going to go highlight my slopes. Again, you go look in front of your x. So are these the same? Nope. But let's go check if they're perpendicular. So perpendicular says that they have to be opposite signs. Yes, that's negative. That's positive. Then the second thing you have to make sure is that they're flipped. Are they flipped? Yes. So we would call this perpendicular. So number 7, these two equations would be perpendicular. All right, let's go to number 8. Number 8 says the line with a slope of negative 3 and the line that contains 2, 4 and 5, 5. All right. They're giving you two lines. The first line they tell you is m equals negative 3. The second line, we got to figure it out using these two points. So we're going to go do y2 minus y1 over x2 minus x1. So ready? I'm going to say these are my y's. So I'm going to do 5 minus 4. Then I'm going to do the x's. 5 minus 2. Okay, so obviously they're not the same slope. Now we got to check to see if they're perpendicular. That one's negative, that one's positive, and these are flipped. If you're like, how are they flipped? You could say, okay, well, I have negative 3 over 1. Yes, you could see they're flipped. So you would say that this line, these two lines, are, if we graphed them, would be perpendicular at a 90 degree. All right, and the last one, you're going to have to find the slope of this line, which is these 2 points, and the slope of this line, which is these 2 points. So we will do the first one. M equals, ready? So the first one says negative 3, 1, 1, and 4, 3. So ready? I'm going to do 3 minus 1. 4 minus a negative 3. Be careful. So this would give me 2. And this turkey right here becomes a positive. So 4 plus 3 would be 2/7. All right, now let's go do the slope on the second 2 points. We have 1, 5, and 3, 12. So ready? I'm going to do 12 minus 5, 3 minus 1. I have 7 over 2. Now this one's trying to trick you because it is definitely flipped, but are they opposite signs? No, they're both positive. And for it to be perpendicular, one of them has to be a negative, one has to be a positive. If this does not work out, you are going to say neither. Why? Because this does not have opposite signs. So you have three choices when you're identifying slopes. Parallel, if they are the same slope. They are perpendicular if they're opposite signs and they're flipped. And if it isn't either one of these, you're going to say it's neither. So, if you guys would get your assignment, pause me if you don't have your worksheet yet. I'm going to do 2 problems on each side. So we're going to work first on the side where it says determine whether the graphs of each pair of the equations are parallel, perpendicular, or neither. So this side's pretty easy. You're going to pull out the slopes, and then you're going to figure out if it's parallel, perpendicular, or neither. So I'm going to do the poopy ones. So I'm going to do number 8 and number I'll do 5. I'll do number 8 and 5. So ready? I'm going to do 5, and you guys are ready. So on this side, I'm going to kind of cut it right here. On this side, I can quickly see that my slope is 2/5. This is easy. But on this one, this turkey, I can't tell the slope. I have to make it look like y equals mx plus b. So ready? I have to get rid of the 5 because they're multiplying to each other. I'm going to do the opposite and divide by 5 to everything. So that goes away. It becomes 1. And I'm going to rewrite this as y equals 2/5 x minus 2. So I'm going to pull the slope out of this one. So the slope is 2/5. So therefore, because they're the same slope, it is parallel. All right, now I'm going to go to number, I'll do 8. So on this guy, we're going to have to do a lot of work, guys. So here we go. We're going to have to make them look like y equals mx plus b. So let's go ahead and get to work. I need to move the 4x to this side. So I'm going to do the doo-doo. Next, I have to get rid of the 5 in front of the y. So I'm going to divide by 5 to everything. So we have y equals negative 4/5 x plus 1. So my slope on this one is negative 4/5. If I went too fast, please always know that you could go rewind. Let's go to the second equation. Again, I need to move the 4x over. Do the doo-doo. This time I have a negative 5y equals negative 4x plus 20. This time I'm going to divide the negative 5. So this gives me negative divided by negative is a positive. Positive 20 divided by negative 5 is a negative 4. The slope on this one is 4/5. This one's trying to trick us also, because they do have opposite signs, but the slopes are not a reciprocal. So if it doesn't meet both requirements, we call this neither. Okay, let's turn to the back. All right, I'm going to do number, I'm going to do number 14. So again, we're going to find the slopes. So the slope for the first one would be 7 minus a negative 6 over 3 minus 3. This becomes a positive, so 7 plus 6 is 13. 3 minus 3 is 0. Anything divided by 0, we call that undefined. If anything's being divisible by 0, it is undefined. All right, let's find the second slope. And this one will be negative 5 minus 8 over 2 minus 2. And again, we're going to end up with an undefined. So this would be the same slope. So we would call this parallel. All right, so the assignment is complete the rest, all front, all back. I did 3 problems with y'all, so these should be pretty easy. And I'll be here tomorrow, and we're going to do some equation writing with parallel and perpendicular. All right, be good. Have a great day. Bye.